So as he said, I'm here to talk to you about reactive Angular 2. My name is Rob Wormald. I'm a developer advocate on the Angular team at Google. So being a developer advocate means my job is basically two things. So part of it is what I'm doing here. So we come out to conferences and we go to companies who are using Angular. We talk to them, we advocate, we tell you how great all of this stuff is. The other part of my job is talking to developers and feeding information back to the core team. A lot of what we do at Google is using the different kinds of infrastructure than we do here in the outside world. So like we don't use Webpack, things like that. So a big part of my job is saying to the core team, hey, this doesn't work with Webpack. Normal humans aren't going to be able to do this kind of thing. So it's kind of a two-way job, and so this is the fun part of it sometimes. So we're going to talk about reactive today. And so I am mildly obsessed with reactive programming. Like, it's probably not a surprise to most of you that I'm here talking about RxJS, right? This is pretty much what I do. Let's jump through here. So when we talk about reactive programming in Angular, it kind of breaks down into 3 or 4 different APIs. And these are kind of the main ones that I think about. There are other places under the hood where we're using reactive programming and observables, but these are the big 4. And these are the ones I want to go through with you today. This is the 5th one, which you probably don't know about. So a little bit of history on this. This is almost 2 years ago now. Yeah, almost 2 years ago now. Jeff Cross sent out a message to the Angular data dev group. So this is a Google group. And this is long before I joined the core team. And he sent out a message that said, hey, surprise, we're going to switch over to observables for Angular 2. HTTP is going to be using observables. We're going to move over to this brand new pattern. And this was before I joined the core team. And so I basically was like, oh my god, what? And so I wrote this big long diatribe, and there's actually like 10 posts where I'm continually going, no, 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 right? And Sandra, who's in the front row here, was actually arguing for it, so thanks for that, right? And so this was kind of my primary thing here, right, is that I think that they're really interesting, I think they're really pretty awesome, but I don't want to make it harder for users, right? Like, everybody who's using Angular 1 had just finished really figuring out how promises worked if you're new to JavaScript, right? And so this is more or less how I felt, right? That like I just gotten promises, I just understood them, and now they were taking them away, right? And so if you feel like that, and this is a question that comes up all the time now, people ask me all day long, do observables make sense? Why are we not using promises? Why are you doing this to me? Why do I have to learn this new thing? And so this is a really good issue to read if you haven't. There's a lot of discussion in here. It goes through a lot of our kind of reason and rationale. But this question comes up. It's a fair question to ask. And I think that's the thing that I really want to answer for you today if you haven't really gotten into using observables. For me, observables are about composition. So it's not about just HTTP or just forms or just any other reactive API. It's about being able to think about what you're doing in a single way. An observable is something that you can really use to represent many, many different kinds of things, many types of different data flows. And if you're using observables for this, it means that it makes it really, really easy to plug one thing into another thing, right? One API that you've got, because it's an observable out and the other thing takes an observable in, all you have to know is how to sort of connect these pipes together. So that's what we're going to go through today and kind of see if I can get across to you what I'm talking about when we talk about composition. So this is a joke that comes up often on Twitter, right? So anytime somebody talks about observables and mentions type ahead boxes, take a shot, take a drink, right? This is a drinking game that we play. And this is the reason we do this is I think this is probably the best example for understanding what we mean when we talk about composition. Back to here. So these are the 3 we're going to use in this example here. So Angular has 2 form APIs, right? There's the the traditional style ng model API, where you're doing two-way data binding, you're mutating the data that you're using in a form. And then we have this new reactive forms idea. And this is, for me, kind of the entry into observables in Angular 2. So rather than doing ng model and binding to some object, what we're doing here is binding to a form control. And so a form control does not represent your data. It represents the actual control on the screen. And it gives you an interface to talk to that thing. So the way we use something like this is we start with a very simple component. I'm just omitting the decorator at the top here because you've all seen what Angular decorators look like. So all I'm doing is creating a new control and just attaching that to the myControl property here. What this gives us is a couple of different APIs. So the first one here is value changes. So value changes is an observable. It will emit to you, it will push to you the value of the text box every time it changes, right? So you type in the text box, a new value comes down the pipe for each letter that goes into the pipe. So this is a stream, right? This is an input into your program. So to use this, and the other way to do this, is status changes, right? So we have the data that's coming out and also the validity of the control. Based on the validators you're using, all of this will be delivered to you. So you get, again, the text spitting out to you, and also basically a true or false that tells you this form is valid or this form is not valid. So these are the two inputs into the system. We're not going to worry too much about the status changes today, and we're going to work with this value changes property. So again, to start with, this is just a stream of text, right? Every letter you type, you get text spit out to you. So let's build a type ahead, right? Let's go through this kind of step by step. The first thing we want to do is bring in the HTTP module, right, or the HTTP service. This is the built-in Angular one, which again uses observables, and we'll see how these things compose together in a second here. The first thing you want to do is inject HTTP. And then what we're going to do is, right, if I'm typing in an input box, and let's say I'm going to query YouTube or something like that, what I need to do is take each letter that I'm typing in the box, right, the word that I've entered, and turn that into a URL, turn that into the thing that I'm going to use to actually do the search. So the first step here is to just use map. This is just like array map that you've used before. It takes one value in, you return the new value, and so all we're doing here is taking the text, adding it to this API string here. We're using a template string in here. So what we get out of here, right, would be the URL with the query attached to the end. And now you can see our subscribe is going to deliver to us the URL we want to use. So simple stuff so far. The next step is to use flat map. Now, flat map is probably the most important operator in the entire thing we're going to talk about here. Flat map is very much like map. Its job is to do a transformation from one thing to the other. But unlike map, what it will actually do is wait for the observable you return from it. So HTTP here, again, returns an observable. So if we were to just straight map that, right, what we would actually get back, what would emit to us, would be an observable. And we don't want that, right? We want the result of the observable. This is very much like promises, that promises unwrap, right? You need to get the value out, and that's what we care about. So flat map will take in that URL, return a new observable, and flat map will wait and deliver the results of this HTTP query. And so the next step then is to actually get the response object. So HTTP returns to us a response observable. This response object has JSON on it. So again, top to bottom, we're getting the text, we're turning it into a URL, we're making a request with that, and we're getting a response out. Are you with me so far? Just a little trick, if you've been doing this before, Ben Lesh, who does all of our RxJS stuff, always yells at me because I forget to show this slide on stage, so I'm going to show it today. FlatMap has this really neat second property here, which allows you to basically do what's called a result selector. And this allows you to do an extraction, do a transformation inside of FlatMap. So it just saves you from writing this extra line of code, right? So again, top to bottom, start with the text, turn it into URL, take that URL, turn it into a request. And now what we're getting out here is actually like the array of JSON responses that we want, right? Now, anybody who's ever built a type ahead knows that the most important thing about type aheads, right, is that you are always going to want the latest value. If you've started typing in a box and a query goes out to the server and the server starts doing its work, and then you decide, actually, I'm going to type another letter, you no longer care about the previous request, right? And it could be possible that one request goes out, a second request goes out, and then they might arrive back in a different order, right? There's a bunch of things here that can kind of get really tricky to manage. And if you've ever done this without observables, if you've ever tried to do this with like set timeout or anything like this, it becomes a really, really ridiculous problem to manage. So this switch map operator here works exactly like flat map. So again, it takes in it accepts an observable, and then it unwraps that observable and delivers you the value. But if a new value is emitted into it, right? So again, I type 1, 2, 3, and then the request goes out, and then I type 4, it actually will cancel the previous request for me. So it will go ahead and cancel the underlying request. And this is actually the reason that we don't use fetch, which I was arguing for 2 years ago when we started talking about this, is that fetch doesn't give us the ability to cancel a request, right? Because it's using a promise, we have no ability to cancel that request. We can't abort it in flight. And so it means that even if we don't care about the results of that query coming back, we're still paying the cost of the bytes, right? We're still paying for that network traffic. And especially on mobile devices, on 3G networks, things like that, this can be very expensive, right? So switch map gives us a very, very easy way to go ahead and just cancel previous requests. It keeps everything in line for us. It keeps everything nice and efficient, and everything works really nicely. So again, text, URL, request, response, automatic cancellation here. And so what you would do, kind of the sort of simple, naive way to do this would be to just have a results property, right, on your controller, on your components. And then at the end here, just do subscribe, and then do this .results, which would make it available to your template. And so we can just do a simple ng4 here and iterate over those results and render the content, right? This is the neat API that I really like, and I think this is a thing that really makes what you're doing with when we start doing composition, when we start doing reactive components, it makes it really easy to think about because you don't actually have to really think about this as an observable. You don't have to worry about subscribing and unwrapping it and getting all the values out. What we can do is instead of subscribing at the end here, we're just going to go ahead and assign this observable to this .results. So rather than results being an array here, results is an observable of arrays. And so the interesting thing about observables is each time that you call one of these operators, so map or switch map or whatever, it will always return you a new observable. So all we're doing here is taking this, going through this sort of flow we're going through and assigning that to this .results. So now this .results is an observable of our responses coming back from our server. And then if we go ahead and use the async pipe here, the async pipe will go ahead and automatically subscribe for us. It will wire up the observable. It will start the work happening. It will unwrap the values, right? So we don't have to do that subscribe, unwrap thing. The other cool thing about the async pipe is that it's deeply plugged into Angular's change detection. So it means that because this value is being pushed to us by the stream, the async pipe can listen for that, and it can use that to actually plug into Angular's change detection. So imagine if you've got a very large, complex UI, you've got a lot of change detection happening. This allows you to really take an entire, let's say, a very complex list view that's rendering these results, bring it out of the change detection cycle. And so when the application is doing its thing, it will actually skip over this list view when doing change detection. And when the async pipe receives a value, it will tell Angular, hey, this is a new value. You need to go ahead and do change detection for me here. And so this is a very powerful tool when you start getting to much, much larger and more complex UIs. So back to the type ahead, right? Again, we start with our resist results. That's being assigned. We're doing our value changes filter. Now, one of the things that's interesting here is that when you're typing in an input box, you probably don't want to do a query with like the letter A, right? It doesn't make sense to just send out A out to the server. And so you probably want to wait until you've got a couple of letters or 2 or 3 letters in the box, right? So we're just going to add filter. This is a simple optimization. And so this means no values will come past the filter pipe unless the text is longer than 2 characters, right? So again, we don't want to send kind of tiny queries to the server. The other thing we want to do is be cautious about how often we're sending these requests out, right? So debounce is something, this is a pretty consistent pattern for this. Again, if you've ever implemented debounce manually using set timeout, it's a really complex thing to do because you've got to deal with the set timeout. You've got to worry about keeping track of the ID of the, the timeout that you've got running on at the moment. So there's a lot of extra state. There's a lot of extra complexity to manage. It's very, very complicated to do debounce without observables. Here it's just one built-in line of code, debounce time. We'll do 150 milliseconds, right? So type a character, it'll wait 150 milliseconds, send the request out. So it's 2 little bits of optimization that are very, very, very easy to do with Rx and just ridiculously complicated to do without Rx. Now, where'd that slide go? So these 2 things here, right? This is like a consistent optimization you're going to do on most sort of type ahead things you do. And so what you probably don't want to do is rewrite this repeatedly, right? Do this again and again and again. So an operator that not many people know about is this let operator. And I think this is actually one of my favorites in Rx. What let allows us to do is take that little bit of logic, that filter and debounce logic, and move it out into its own function. And so what we can do is say, let's do filter and debounce as its own function. This function will accept an observable, accepts an input stream, and then we just have to return a new observable back from it, right? So it gives us a sort of pipe section that we can plug into any sort of observable stream. So in this case, we're going to take the input, we're going to dot filter it, right? Do the debounce. And to apply that, we just use the let operator, and we can pass our function in. This is super, super useful for reusable logic. Doesn't have to have DI. You don't have to get involved with it. It's a very simple function that you can reuse all over your application. You can also get a bit clever here and do function composition with this stuff. So we're just going to expand that function slightly, and this is going to be a function that returns a function that returns an observable of our stream. So this allows us to pass arguments into it, for example. So this time we're going to take the delay in, then take our input stream, filter, and debounce it based on that delay. And to use that, we can just do filter and debounce and call that function and pass the arguments in. So you can do this, to kind of a crazy extreme, but this is a very useful thing to have reusable bits of logic. You can compose into slightly larger reusable bits of logic, share them on GitHub. They become very, very portable, nice little functions. So the router is the other big observable thing in Angular 2. The first 2 iterations of the router had some basis in observables. There were some things you could listen to. But in general, the first 2 iterations of the router were mostly based on promises. And when you think about it initially, that makes sense because you're going from A to B, right? And you want to make sure that that completes. Promises make sense as a mental model for that. But when we looked at the second API, or when we looked at the third API of building the router, and one of the things that had happened is that in the interim of us rebuilding routers, the NGRX team had actually built a whole brand new reactive router, right? So they'd kind of totally thrown out an entire idea of how we were doing routing, and had really built a new thing up from scratch. And I think that when we as the team looked at this thing, it became pretty clear that this was maybe a better model for how to think about doing routing, how to think about applications, and how to think about you moving around your application, because this is really, it's a stream of actions, it's a stream of routes, query parameters. All of these things are inputs that are consistently changing to your system, right? So it makes it, it gives us a really consistent API to work with routing. So imagine we wanted to build like a list detail view, right? So we can use Angular's router to do this. We have a list on the left side. We have a detail on the right. We might have our list of users coming off the server here, and then we want to render kind of the user's profile in the right box here. So if we think about the left side, that's going to be a list component, right? We'll call that our list component. We're going to just bring in an imaginary user service here. This user service is going to have a fetch users method, which returns an observable again. So this user becomes an observable of user. We're just going to assign that. I really like this because, again, there's no real logic in here. There's nothing really happening. You don't have to think about this too much. It's just a question of basically using this component to connect your service and its data to your view, right? It's a very thin layer, a very nice, easy to reason about kind of connector. And then our details component will be the right side thing, the thing that will show our kind of consistent user profile. That's going to inject 2 things. It's going to inject the user service, and it's going to inject the activated route. So the activated route is delivered to every Angular component that is routed to. It will give you the information about where you're at, what parameters you have, arguments, things like that. And so the first observable API in the activated route is params, right? So if you've got user:id in your route configuration, route.params will deliver that information to you. And interestingly, rather than, if you go from user 1 to user 2, rather than destroying that component and reinstantiating it, right, what this allows you to do is keep the same component on screen, reuse that repeatedly, and just react to the parameters changing, right? So again, this is going back to the idea of composing this stuff. You can actually almost think about this exactly the same way as our form control, right? This is just an input into the system. It's a stream of information that we can then pick up on and start doing interesting things with. So start with our user service. What we're going to do, the other thing to mention here is that we have our activated route params here. And then the router actually exposes query parameters, right? So the question mark on the end of your URL, that's exposed as query parameters as well. That's exposed as an observable that we can subscribe to. We treat query params as a global thing. Query params are global to your entire application, whereas activated route and their specific params are only specific to the route that you've activated on. So there's 2 ways to handle this thing. Both of them observable, again, both of them using the consistent interface. So again, we'll do this whole thing again, right? So we're going to do route.params. We're going to flat map. We're going to get those parameters coming off of our router. So as we navigate around, flat map's going to emit to us this new value each time. And then we're just going to call our user service with a method like getUserById. We're going to pass in the params.id. This will make a request to a backend server, again, returning an observable here and rendering that back out. So we're just going to get the user profile back from this call. One thing that's nice about this, going back to that switch map idea, right, is if you have a user who's clicking around your application in a very fast way, right, so he goes from 1 to 2 to 3 to 4, and there's a delay while the API comes back, this will, again, automatically cancel the in-flight request for you. So it keeps things efficient. It means you're not wasting bytes. Again, it's just one line of code to add that to your controller. So again, we'll do our subscribe here, user profile, we'll log it out. So just to refactor this a little bit, again, we'll go back and go ahead and eliminate the subscribe from our component. We don't want to deal with that. We don't want to mess with any of that. We'll just assign the user observable to the component, and then we will use the async pipe in the template to do this. One thing I want to mention, and Victor pointed this out to me before I came here, and he said, you have to mention this, right? You have to talk about this, is that basically we see a lot of people who are subscribing and then unsubscribing, right? So they're managing the subscriptions manually here. The neat thing about the router is you don't actually have to worry too much here about cleaning up, about unsubscribing. You can just listen to the thing, and then when that component dies, that observable will die, and the listeners will die. And so you don't have to worry about memory leaks with the router in this case. It's a really, really nice, clean way to deal with things. So this is what it would look like if we took that observable that we've attached to our view, right, and rendered it. Now, I don't know about you, but I don't think right now that this is the nicest syntax, right? Because we're worrying here about two things. We're worrying about the asynchronous pipe here. We're worrying about async pipe. And then we're dealing with our question mark, right? And so this is the, we call it the Elvis operator. We get yelled at when we call it the Elvis operator. So I think it's called the safe navigation operator. Mishko, not if that's ish. Mishko doesn't know either. That's why we call it the Elvis operator, right? So the Elvis operator will wait, and it means if that value is undefined or null, it will not try and resolve the next value. So this means it doesn't explode with, name is not a defined party. So it's something that it's safe. It makes things easy to work with, right? But I don't think that it's particularly beautiful yet. The other gotcha about this that you should be aware of is that what we're actually doing here is subscribing 3 times this observable, right? Because each of these async pipes is currently subscribing to the observable. Now, this is less problematic in a situation like the router, but because observables can be resubscribed to, you can get into trouble here if you actually subscribe to something like an HTTP request several times. It will actually send out multiple requests out to the API, which is generally not what you want. So there's a couple of ways you can handle this. One of the things you could do is use one of the built-in operators like share or there's share, we've got cache, we've got publish behavior. There's a number of different ways to handle this at the observable level. The other thing to do is actually think a little bit differently about how you lay out these components. This is a pattern that we'll talk about here in a second, and this is a pattern that we've very much learned, or I very much learned from React and Dan Abramov and things like this. This is a way to think about how you compose views in your application. So let's refactor this slightly, right? So we're going to take our detail container component. This doesn't change very much. We're going to assign the this.user to our controller, and this is what we're doing the async subscription to. But instead, what we're going to do is instantiate a new component. We're going to create a new component to actually host our profile. So we kind of call these things smart and dumb components, or if you prefer, presentational components and logic components, or there's a number of different ways to describe this. But really what we want to do is divide up the responsibilities of these components, right? So we want to have one component whose job it is to talk to the server, to go get data. It's very specific to the place that it lives in your application. These smart components, they're going to do DI, so we'll go back and look at this again. This is a smart component, right? It has dependency injection. It's pulling in services. This is not something that you could typically reuse in multiple places in your application. And trying to do so will often lead to your code being more complicated than it needs to be. So what you do is sort of accept the fact that this is a very thin component, that all it's going to do is serve as the interface between the outside world and the bit of rendering that we want to do. Go forward a bit. So if we create a profile component here, we just create our template. Notice in here that we're not dealing with asynchronicity at all. There's no async functionality in here. There's no Elvis operators. There's no question marks. It's a very, very simple component. The net result is the same, right? But inside of this, you don't have to worry about any of the stuff that's happening in the outside world. So the profile component just takes input from the outside world. So it's got an input. It's got a user, right? And so all we really have to care about here, and all the component has to know about, is it is handed a user. It's handed a user object, and its job is to render it. Doesn't care where it comes from. Doesn't care if we're using it in a test, or if it's coming off of a server, or we're using it in the router. So this profile component becomes very, very reusable. And more importantly, becomes very, very easy to test, right? Because you don't have to worry about mocking it out. You don't have to worry about any of this stuff. It's a very simple, reusable component. And so then we want to use it, right? We've got our original user profile header, and then we can just use our user profile components assigned to the input property there. So we're going to bind with our user brackets here. And then we use the async pipe once, right? So this brings all of the logic into a single place. The async pipe here handles that single subscription, handles the values coming in off of the server, allows us to really not worry about that component on the inside. So one kind of missing piece for me in Angular 2 right now is we've got a really, really good story for how to get observables from services, from the router, from all of the various observable APIs in Angular. And so we can do a really good story on output to the view, right? Model to view is really, really well done at the moment. And we've got a really, really good story for data coming off of forms, right? We talked about the forms API. So when you're typing in input boxes, things like that, we've got a really, really good story for that, and I think it works really well. The thing that we're missing at the moment, and this is an API that when we get back from this, I really want to start working on, is how do we think about all of the other events that are coming in from your interface, right? So if you consider something like drag and drop, right? That's not something you can describe in a form, or button clicks, right? We can currently do the sort of the parentheses syntax and assign to a method. But if you're thinking about this stuff observably, if you're thinking about this in a reactive way, again, really what you want is the input into your system to be an observable, right? And that means that downstream from that, you don't care about what's coming from it. It's just an observable of data. So this is kind of an experimental proposal that we've been working on for a little while. And the idea here is that very much like the query decorators that you have in Angular today, so you've got view child and view children and content children and content child, which query for elements in the view, right? So view query allows you to say, I want to find the sum components, observe child, for example, and we're still working on the name, so if you've got suggestions, send them in, because I don't love this name at the moment. This would allow us to query for the sum component, right? And also then listen to events coming off of it, clicks, drags, whatever. Ditto for the second one there, which is actually looking for a selector or for a target thing, and we can listen to any custom event coming off of that. So this would give us the ability to do really, really powerful composition and say all data coming in from these views is an observable, and then it's easy to switch map, flat map, all this stuff that we were just talking about, really to make the whole story end-to-end observable. So if this is something that interests you, we've got an issue. It's 4062 on the Angular repo. I'm going to get Mishka in trouble here. I'm going to say, if you like this API, Mishka's in the front row, so come and tell him that this is something that we should do, right? Because I've been trying to convince him for a little while. Cool. That's it for me. I'll be here all day, so if you have questions, comments, you want to talk about observables, come and see me. I should mention, I was talking to Paul yesterday, if you want to get an idea for how this works in the real world, what it looks like to build a really complex, really solid type ahead with this kind of stuff, look at NG Bootstrap, because they've done a really, really good job with their type ahead implementation to get a, sorry? I'm talking about. Oh, good. He's going to show you later a real, kind of real world example of this. And so it means it's not something we're just showing on stage, it's something that I think actually works. You like it? Yeah, it works good? Great. So that's me.